Today we're going to talk about the physical layer and how you control things like enabling, disabling ports, port speed, flow control, power over Ethernet, a little bit of kind of how the operating system works, and how you can manipulate the physical layer. So without further ado, let's look at the physical layer. So one of the main things people want to look at are the interfaces themselves. So if we are in configuration mode, as we are right now, we're going to do a run show interface brief. If I'm going to spell brief correctly. And we can see all the different ports. And right now, all the statuses on the ports are down. Now, given that the two devices I have plugged into it all require PoE, why don't we cover the PoE first? Let's cover that. So PoE is kind of an interesting thing because on some switches support it, some don't, so this may not apply to your specific situation. But we have two ways to enable power over Ethernet. The first one is that we can set all PoE interfaces set PoE interface all enable true. And then we commit it. That is going to turn on PoE for every port. Now, that's very nice. However, I can go in and turn off power on a particular interface. But before we do that, let me show you what it looks like. So we're going to do a run show PoE interface all. This shows us the PoE power on all interfaces. You can see that I have two devices here. We have one on 111 and 112. Slightly different. One's a power class 4 and one power class 2. This one in port 1 is a wireless AP, and the one in port 2 is a PoE. A VoIP phone. We can also do a run show PoE power, and that's going to show us the overall power consumption and how much is still available and how much has been allocated, and real-time consumption, how many power supplies we have, and just the total power budget that is available. Now that these two devices are on, when I run show interface brief, I will actually show two ups. So GE111 up and up. The next thing we can look at, and your mileage will vary on this one. If you have switches attached or some endpoints, some devices will actually produce something when you do a run show LLDP neighbor. And I think that's what we run. So you can see here that I have one neighbor that shows up. All right, so back to looking at the physical layer. Let's look at how to enable and disable a port. So we have a couple of ports enabled here, so we're going to do a run show interface brief. Show that we got two ports, GE111 and 112. We can set interface gigabit Ethernet GE111 disable true. That's going to turn the port off. Now when I look at my brief status, I have not committed it. Let's go ahead and do a commit. So I issued the command, but I didn't commit it, therefore the interface did not go down. And now you can see that it is disabled and down. And remember, we're still in evaluation mode. We do not have an official license on this, so ports 5 and up are all going to be disabled by default. And then on this particular switch, GE1124 and TE111 are enabled. Oh, sorry. TE111 and 112 are both enabled because that's what we're licensed for. So I went ahead and disabled 111. In order to re-enable it, I would run this command, disable false, and commit it. And it's back up and running. Now we can also set the MTU. That's something that is fairly commonly done. MTU, and we can set that to 1200 or something like that. We can also turn on and off flow control. Set interface, gigabit Ethernet, GE1 Ether options, flow control, true, and commit those. Auto negotiate does work best on works on most switch models, but if there is a problem, you can set the port speed manually. We would do that through set interface, gigabit Ethernet, GE. Actually, we won't get anything on GE, so let's do TE111 and speed. And you'll see that there are a number of options. Of course, auto is the default, but I can go ahead and set it to 1000, for example. And now that port that can do 10 gig is now set to 1000. And again, I can look at that with my show interface brief. It's not going to give me the detail on the settings I have. Oh yeah, actually it will. So I'm set to 1 gig. It's not set to auto. Up here, these are set to auto, but they have negotiated to 1 gig. So that's important to know. And do know that you can also run GE-1-1-1. Oh, I thought I was going to get that one. Interface, gigabit Ethernet, GE-11. Now I get detailed on it. I can also look at TE and see that, again, we have set the speed to 1 gig. The MTU on this one is set to 1518. I set it to 1204 on GE111. So you can see that those values have been applied. Next is, and I can't show you on this one because I don't have 40 gig or 100 gig ports, but if you do have a switch model that allows, that has 40 gig or 100 gig, you can apply breakout cables to them. And when you do that, you're actually going to set the interface, and I'm not sure that I'm actually going to be able to see this. Let's see, on the TEs, maybe there is this breakout command. Well, and I don't have that on this one because it's not capable. So it would be something like XE 1/1/1 breakout true and commit that. And then when you do use a 40 gig or 100 gig and break those out into 10 gig ports, then those models are going to show up. I'll show you here, show interface brief. So say this one was an XE 111. Then when we broke it out, it would be 111.1, .2, .3, and .4. You can always look that up in the documentation for more information. All right, some other very useful commands are run show LLDP neighbor, which shows you again who you're connected to. This is more exciting when you're connected to other switches. We've already done show interface brief and the way to show detailed information on a specific interface. And those interface commands, we treat aggregation ports as regular interfaces. So instead of like doing a show interface gigabit Ethernet and putting the port number, that produces some output. You can also do the same thing with show interface aggregate Ethernet and then put one of the aggregate Ethernet numbers in that you have in use, and it will show you very similar information on the aggregate. All right, well, that's it for the physical layer, and we'll be covering switching in the next module.